Okay, so as we continue, not completing the square, but as we continue to learn how to solve quadratic equations, one of the methods will be to use the completing the square. And what we are doing here is we are focusing on how would we create a perfect trinomial square, because when we have that trinomial square, if I have, for example, x plus 1 squared. Now, that's a square trinomial. And if I were to turn that into equation and say equal to 1, well, I would be able to solve this by using the square root because I have what appears to be an item that is being squared. So in practice, I could remove this squared by finding the square root. And of course, if I found the square root of both sides, then this would simply, my square root is going to cancel out my second power because of my exponent rules. And I would simply have x plus 1 is equal to the square root of 1, or it turns out, that's plus or minus 1. So in using this completing the square, it allows us to sort of simplify our problems and decrease a little bit of our effort as long as we can recognize that square root property. So let's see here. As we talk about completing the square, in order to complete the square, you need to know what is going to create a perfect trinomial square. And what I've done is I've included an example here. Finding c to complete the square. Well, c is going to be that constant value. It's going to be that constant value that would have allowed this to be a perfect square trinomial. And in order to do that, well, I would turn around and see here says, what is the value of c such that the expression is a perfect square trinomial? Well, I would want to take, in order to find c, we take b, divide it in half, and then square it. So I would have negative 16. Half of negative 16 is going to be 8. It's going to be negative 8, and then negative 8 squared gives me 64. So c would have to be 64 in order to complete to have a perfect square trinomial. And when we factored that, of course, we're looking for factors of 64, which combine to give me negative 16, and that would be x minus 8 and x minus 8 written as x minus 8 squared. So that was our end result and our end goal. So as we go on to the next example, we're looking for example B. We have r squared plus 20r equals c. Well, in order to find c is going to be 1/2 of b squared, which is going to say b is, gosh, you got to remember that that's b is 20. You got to remember that a is 1. And we're looking for what the heck is c going to equal, right? So I have c is equal to 20 divided by 2 squared, which is going to be 10 squared, which is 100. So again, I can rewrite this r squared plus 20r plus 100. And in doing so, you could factor that, and it's going to be r plus 10 times r plus 10, which is r plus 10 squared. So that's our goal. And of course, completing the square. And again, this last one, if you notice, c, it says x squared minus 20x plus c. Well, again, we're taking half of this and going to square it. So c is going to be equal to negative 20 divided by 2 squared, which is going to be equal to negative 10 squared, which is 100. Right here. So it looks at c turned out to be the same value. And you may understand why c became the same value. But when I go to replace it, I'm going to have x squared minus 20x plus 100. And there you go. There's my answer. And when I factor that, you may recognize that it is going to be x minus 10 times x minus 10, and which is x minus 10 squared. Hey, you got to remember, why did we end up having a positive 20 and a negative 20 result in the same value of c? Well, remember, when you square something, it's always going to become a positive number. So negative 10 squared is positive 100. A positive 10 squared is a positive 100. So again, all of these mathematical practices keep coming back, and we keep using them over and over. Now, using the method of completing the squares, we go on to section 2. It says we're solving now, and we're going to go ahead and solve this equation. And if I look at it quickly, x squared minus 14x plus 16, there are no factors of 16, which when I combine them will give me negative 14. Now, so it's not an easily factorable problem, and that's why we're going to go to the effort to create a perfect trinomial square and go ahead and solve it this way. So in order to begin the process, I need to make sure that I get my a and b by themselves, and means I'm going to move the rest of the information over the current c value. I'm going to move that over to the other side of the equal sign. So I moved that over, and I ended up with x squared minus 14x equals negative 16. Then I went ahead and found what value, again, would make this a perfect trinomial square. So when I took half of c, or half of b, and squared it, I came up with 49. So when you add something to one side of the equation, you must add something to the other side of the equation. So in this process right here, to get this negative 49, I used what we did in step 1 to figure out how to make a perfect trinomial square. So I've gone ahead and simplified the left-hand side over here. I have negative 16 plus 49 is going to give me 33. And recognizing this, when I factor this perfect trinomial square, it's going to be x minus 7 squared. And that was the reason that I created that. So I have this square equals 33. And now that I have my something in squared, I can go ahead and use the square root to get rid of that. So again, you know, the square root is going to counteract that squared power. And so I found the square root of both sides. So I have x minus 7 is equal to plus or minus the square root of 33. So then as we continue on, now there's no longer a mower running in the background, I found that the square root of 33 is roughly approximately 5.74. So I have x minus 7 is approximately equal to 5.74, do my inverse operations, and I get x is approximately 12.74, or x minus 7 is approximately negative 5.74, doing my inverse operations, and there you go, my two solutions are x is approximately 12.74 or 1.26. So using the square roots, and in class, we may simplify square roots sometimes, use them as decimals, just depending on what's going on and what resources we have available to us. So as we go on with these examples, again, I want to do my inverse operations here. I have x squared, or completing the square, x squared plus 9, x squared plus 9x plus something, right, is going to equal, and I'm going to go ahead and move that negative 15 over to the other side, plus whatever that value is. So again, half of b squared is going to be 4.5 times itself, I think comes to 20.25. Let me check that. Okay, and adding that to both sides, you're going to be able to factor this side. That is going to equal this over here, which is going to be 5.25. Therefore, let's see. Now we can do the square root of both sides. To isolate the x, and of course, I get x plus 4.5 is going to be equal to plus or minus 2.29. Or I'll tell you what, instead of doing that, let's go ahead and just leave it with a plus or minus the square root of 5.25. Now when we have or simplify, we got x plus 4.5 is equal to the square root of 5.25, or x plus 4.5 is equal to negative square root of 5.25. And going ahead and isolating my variable, I'm going to subtract I'm going to subtract negative, I'm going to subtract 4.5 from each side. And x is going to be equal to the square root of 5.25 minus 4.5, or x is equal to negative square root of 5.25 minus 4.5. And if we needed to later on, we could work out that decimal, but right now we can just leave it as a radical. And continuing on, one of the examples that we did in class today here, I'm going to go ahead and add 20 to both sides. So I'm going to have x squared plus 12x is equal to 20. And then I'm going to have 20 plus some number of c. And let's see, so in order to find c again is going to be half of b squared, which we know b is 6. Half of 6 is 9, or I'm sorry, we know b is 12. Half of b is 6. So that would be c equals 12 over 2 squared, which is 6 squared, which is going to be 36. And of course, we're going to add 36 to both sides. When I can factor my left, I get x plus 6 squared, and that is going to be equal to 56. And again, we're going to go ahead and find the square root of both sides. And I know that x plus 6 is equal to plus or minus the square root of 56. So we have x plus 6 is equal to the square root of 56, or we have x minus 6 is equal to negative square root of 56. So again, doing my inverse operations, I have x is equal to the square root of 56 minus 6, or x is equal to negative square root of 56 minus 6. And there you go. Those are our answers, possible answers using completing the square. Now, again, a lot of my students hate these fractions when it comes out to it, but let's see, we have, we're going to have g squared plus 7g plus some number of c that we're going to calculate is equal to 44 plus some value. Again, so c is going to be equal to 7 divided by 2 squared, which is going to be 49 over 4. And if I add both sides, I can leave it as a fraction. Let's see here. So when I factor the left, of course, I get g plus 7 halves squared is going to be equal to, what is this equal over here on the right? All right, so 144 should be 576 fourths plus 49 fourths is going to then simplify to, let's see here, g plus 7 halves squared is going to be something over 4. So we have 625 over 4. And then I can go ahead and find the square root of both sides. And so my left-hand side becomes g plus 7 halves equals, now this is, remember, this is going to be the square root of 625 over the square root of 4, which is going to be 25 over 2. So that is going to be equal to plus or minus 25 over 2. So I'm going to have g plus 7/2 is equal to 25 over 2, or g plus 7/2 is equal to negative 25 over 2. So let's see here, minus, do my inverse operations on both sides. So g is going to be equal to 18/2 or 9, or again, inverse operations. G is going to be equal to negative 32 over 2, which is negative 16. So G is equal to 9, or G is equal to negative 16. So those are my possible solutions using completing the square. Now we're going to go look at completing the square in terms of the vertex, because that's probably the main, if only, reason that we use completing the square, is to be able to turn something into vertex mode. Or at least that's the uses that I have found to be beneficial. So remembering that my vertex form is going to be y equals x minus h squared plus k, and of course h and k, my h and k are going to represent my vertex. So by being able to transform these standard forms into vertex form, I can find my vertex rather quickly. So looking here, what I've done, the problem is set up a little bit differently. So I don't have a perfect square here, but what I'm going to do is increase this amount. I'm going to go ahead and create the perfect square by adding the value of 0 to my function. And what I mean by there, instead of adding 9 to both sides in this case, we're going to add 9 and then subtract 9, which will give me the value of 0. So half of b would be 3. I would square that, and I would end up with a 9, right? C is going to be 6 divided by 2 squared, which is going to be 9. And then I'm going to add 9 and subtract 9, because that'll give me the value of 0. Then I take this and I turn it into my perfect square trinomial. And then I just combine what was left over, which is 8 minus 9, which gives me negative 1. Now that I've done that, I can go ahead and factor this portion right here that I've identified in parentheses to be x plus 3 squared minus 1. And we hopefully can look at that vertex form and know that h is negative 3 and k is negative 1, bringing that down here to my ordered pair of my vertex. So again, we're creating C. That's is just one step of our equation and finding the vertex form. So let's see here. So starting off here is I don't have this and I don't have the square, so I know that I need to take y is going to be equal to x squared plus 4x plus some number of c minus that value of c plus 10. So again, c, I take half of b, which is going to be 4 divided by 2 is going to be 2, and I square it, so I get a 4. So there's my c, so I can create that trinomial, but if I add 4, I must also subtract 4 to maintain that balance. So I have y is going to be equal to, when I factor this, it becomes x plus 2 squared, and then I go ahead and combine my like terms over here, and that's going to be plus 6, and then my vertex is hk, and here my h is going to be negative 2, and then my k is going to be 6, and that is my vertex. There. And on this last one, instead of doing something, let's see if we can try a shortcut. Now, we know in order for this to be a perfect square, we have y equals x squared plus 12x. And now what can I do to create a perfect square is going to be to, I need to have 36, right? 36 would create a perfect square because c equals 12 divided by 2 squared, which is 36. I don't have that, but I do have 34. So think about it this, instead of just adding 36 to both, adding and subtracting 36, why don't I just add 2, which gives me 36, and then subtract that 2. That gives me the value of 0, and it does give me that 36 that I need to go ahead and factor. So I can go ahead and factor that portion of my function here. So I have y is going to be equal to x plus 6 squared and then minus 2. And I just created that vertex mode, vertex form, without doing a bunch of any more adding and subtracting than necessary. So my vertex is going to be -6, -2. And in case you forgot, you want to remember that your h is always going to be the opposite sign here based on its formula. The formula is -h, so that's why we always have the opposite sign. So let's see here, going on to using some real world applications, right? Let me go ahead and darken some stuff in here. Let's see, looks like I have this. Okay, I've gone and filled in my drawing a little bit, and it says you're planning a flower garden consisting of 3 square plots surrounded by 1-foot border, and the total area of the garden and the border is going to be 100 feet squared. What is the side length x of each square foot? Okay, so in each square foot. Okay, so let's see here. If I look at this, I was able to come up with, I have x plus x plus x is going to give me 3x plus 1 and 1, so it's going to be 3x plus 2. And then my height here, or width, however you want to look at it, is going to be x plus 1 and 1, which is x plus 2. Now, in order to figure out the area is length times width, and they told me my total area is going to be equal to 100 feet squared, and I know that the area is going to be equal to x plus 2 times 3x plus 2, and that is going to equal 100. So what do I need to do here? You're planning that. What is the side length? Well, we need to solve for x then. And in order to do it, I'm going to have to do some multiplication first. And I'm going to have x times 3x plus 2 plus 2 times 3x plus 2 equals 100. And I get 3x plus 2x plus 6x plus 4 equals 100, and I get 3x squared plus 8x plus 4. And let's see here. Okay, in order to continue here by completing the square, we're going to need to, our coefficient leading coefficient needs to be 1. So what I can do is, let's see here, get some orientation. I'm going to subtract 4 from both sides, and I'm going to, which is going to give me 3x squared plus 8x is going to be equal to 96. And then I can divide everything by 3 to make my leading coefficient 1. And that is going to give me x squared equals, x squared plus 8/3 x is going to be equal to, not 96, but 32. Now I can go ahead and complete the square. So I have x squared plus 8/3 x plus some value is going to be equal to 32 plus some value. And half of, when I take b, c is going to be 8/3 divided by 2 squared, and that is going to end up giving me 16 over 9. 16 over 9. So I know when I can go ahead and factor that, that's going to be x plus 4/3 squared is going to be equal to approximately, or equal to, 304 over 9. Now when I go to do my square root of that, I should be getting, oh gosh, let's see here, x plus 4 over 3 equals plus or minus, that is going to be the square root of 304 over 9, which we can put that into a calculator, and it's going to tell me that that is going to be approximately 5.81. Okay, so then we have x plus 4/3 is equal to 5.81, or x plus 4/3 is equal to negative 5.81, and then we end up with, so we have x is going to be equal to approximately 4.48, or x is going to be equal to approximately negative 7.14. The negative answer is not going to work for us because we can't have a negative length or distance, so it turns out that x is going to be equal to 4.48 feet, and that is what x for each one of our square plots is going to be. Now, if we continue on, it says, suppose that the total area of the garden of the border is 100. Total area of the garden and border is 150 feet squared. Well, what is the side length x of each square plot? Well, you should be able to see then that if that's the case, all of this other stuff is set up the same, except for instead of our area equal to 100, it's going to be 150. So we're going to have 3x squared plus 8x plus 4 is equal to 150 right here. And then when we do our division, of course, we're going to have some other stuff. But I can probably take that, bring it down here, and go ahead and work with it. So we know that that is going to be equal to 150 feet squared. And looking at that, I'm going to have 3x squared plus 8x plus some value is going to be equal to 146. And then, of course, we're going to do everything divided by 3 again. And I'm going to have x squared plus 8/3 x. It's going to be equal to 146 over 3. And then, of course, half and square it. So we're going to get 16 over 9 again. And that is going to equal, what's 146 times 3? That's going to be 438 over 9 plus 16 over 9. And that is going to become 454 over 9. And then that is going to be equal to, just like before, factoring this side, going to be 8 plus 4/3 squared. Sorry, x plus 4/3 squared. And we're going to go ahead and find the square root of that. Okay, so that becomes x plus 4/3 is going to be equal to plus or minus 7.1. So I have x plus 4/3 is equal to 7.1, or x plus 4/3 is equal to negative 7.1. And this is going to be using my inverse operations. X is going to be equal to 5.77, or again, inverse operations. X is going to be equal to some negative number. Well, that's not going to be a possible answer, so it looks like my x is going to be equal to 5.77 there by completing the square and solving my quadratic equation. Again, the process here is, once you do it a couple of times, it will make much more sense and the practice becomes habit. But the big thing is being able to take a quadratic equation in standard form and convert it into the vertex mode, and then being able to graph it rather quickly by recognizing those characteristics. So again, completing the square, it's a process. Once you've done it some, it will be very easy. You just have to do the practice to get to it to be easy.